Hi guys, this is your Chapter 8 review. Some things to remember at Chapter 8 is that we were trying to solve right triangles. And when we say that, we mean we're trying to find missing pieces of the right triangle. So maybe you know some things about the right triangle and you are supposed to find one of the missing angles, or you're supposed to find a missing side. We learned 3 different ways to solve right triangles. And I want to just remind you really quick about when to use each one. So the Pythagorean theorem, you're going to use that when you know 2 sides of a right triangle and you want to know the 3rd side. Okay? In a right triangle, the 2 sides that make the right angle, those are called the legs. And then the side across from the right angle, that's called the hypotenuse. That's always the longest side as well. Okay, so the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Or another way of saying that is a squared plus b squared equals c squared, where c is the hypotenuse. A and b are the legs, and it doesn't matter which leg is A and which leg is B. Okay? And then we also learned that all 45, 45, 90 triangles look the same. Okay? So there's always some number here. That could be a decimal, a fraction, a whole number. It could be anything. Whatever that number is, the other leg is the same exact thing. So we call them both n because they match. They're the same. And then the hypotenuse is the leg, n, times the square root of 2. Okay, and we'll practice some of those here in a little bit. And then for a 30, 60, 90 triangle, it also has its own special ratio. All 30, 60, 90 triangles are in this ratio. This short leg, the one across from the 30, that is n. Okay, that can be a decimal, a fraction, a whole number, a square root. It can be anything. Whatever n is, the hypotenuse is 2 times that. It is double. Okay, so if this is 5, this is 10. You get the idea. And then the long leg, the leg that's across from the 60, that is n times the square root of 3. So again, we'll practice that here in just a little bit. Okay? And then finally, trigonometry. When do we use sine, cosine, and tangent? You're going to use trigonometry if you are trying to find a missing angle. Okay? Or if you're trying to find a missing side and you only know one other side. So if you knew 2 other sides, you could use the Pythagorean theorem. If you know 2 sides, you can find the 3rd side. Here, if you only know one side and you're trying to find another side, you're going to need to use trigonometry, either sine, cosine, or tangent. And we'll talk about when to use each one as we do some examples here in just a second. Okay, so first I'm going to show you just a refresher on some Pythagorean theorem problems, okay? So you'll be given a right triangle, you'll know 2 sides, and you'll be trying to find the 3rd side. So maybe this is 5 and this is 12 and you're trying to find x, okay? Or maybe this is 10 and this is 20 and you're trying to find x. So sometimes you'll be trying to find the hypotenuse, sometimes you'll be trying to find a leg. On either one of these, you can use the Pythagorean theorem. Okay, and remember that's leg squared plus leg squared equals hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. Okay, you can plug this into your calculator or do it in your head either way. 5 squared is 25. 12 squared is 144. That's equal to x squared. Add those 2 numbers together. So we get 169 equals x squared. And then we take the square root of both sides. Okay, the square root of x squared is just x. The square root of 169, you can plug that into your calculator, you get exactly 13. So there's your answer. Now over here, we're going to do the same thing. Leg squared plus leg squared equals hypotenuse squared. So leg squared plus leg squared equals the hypotenuse squared. So notice sometimes your hypotenuse is x, sometimes your leg is x. Okay, so we get 100 plus x squared equals 400. And then we're going to subtract 100 from both sides. And we get x squared equals 300. And then we're going to take the square root of both sides. On the left, I get x. On the right, I'm going to plug that into my calculator. Okay, I'm going to zoom in here for just a second. So I get square root 300. Hit enter. I get a decimal, okay? And that decimal keeps going and going and going. I can't even see all of the numbers. So I don't want to write down this number. In fact, I can't write down this exact number because it keeps on going and going and going. So I would have to round it. I don't want to round, okay? I want the exact answer. So instead of rounding this, I'm just going to go back to the square root of 300. And I'm going to see if that can be simplified. Okay, so I'm not going to plug it into the calculator. I'm just going to simplify the radical, okay? So I'm going to ask myself if 300 is divisible by any perfect squares. And remember, perfect squares are numbers like 4, 9, 16, 25, 36, 49, 64, 81, 100, okay? This is 2 squared, 3 squared, 4 squared, 5 squared, all the way up to 10 squared, okay? And there's more of these, they keep going, okay? But is 300 divisible by any of these perfect squares? The answer is yes, it's actually divisible by several of them. 300 is divisible by 4, okay? I can take 300 and divide it by 25, or I can take 300 and divide it by 100. I want to pick the biggest number. So 300 can be divided by 100. So what I'm going to do is I'm going to copy down the square root. Okay, I can't get rid of it. It's there. I have to keep it. And I have to keep 300 as well. But I can write 300 in a different way. I can write 100 times 3. That is 300. So this says square root of 300. This says square root of 300. And then I simplify. The square root of 100, a simpler way of writing that is just 10. The square root of 100 is 10. And then I still have the square root of 3. And that's a decimal, so we leave it as the square root of 3. This is our final answer. Okay, so those are what Pythagorean theorem problems look like. You know two sides, you're looking for the third. You know two sides, you're looking for the third. Okay, now we're going to do a refresher on some 45-90 problems. Okay. So for the 45-90 problems, we're going to want to look at this triangle. Give me just a second, sorry. Okay. So in a 45-90, let's say that they give us one of the sides. We can find the other two sides. For example, if they give me 5 right here, I can look up at this model triangle and see, okay, in a 45-90, the legs are always the same. If this one's n, this one's n. Okay, same thing here. If this one's 5, this one's 5. They're the same thing. The legs always match in a 45-90. Okay, and then the hypotenuse is your n times the square root of 2. So whatever this is, times the square root of 2. So this is n square root 2. This is 5 square root 2. Okay, let's do another one. Okay, sometimes it's slightly more complicated. Remember, n can be anything. N can be a decimal, a fraction, a whole number, a square root. N can be absolutely anything. So let's say that it is 3 square root 2. That's your n. Okay, that means the other leg has to be the same thing. Remember, the legs match. So if this leg is 3 square root 2, this leg is 3 square root 2. And then this hypotenuse is n times the square root of 2. So n square root 2. And then that can be simplified. Square root 2 times square root 2. That's simply 2. So I have 2 times 3, which is 6. Okay, let's do another one of those. Okay, so let's say that this one is 7 square root 2. Well, then the other leg has to be the same thing, 7 square root 2. And the hypotenuse has to be 7 square root 2 times the square root of 2. N square root 2. Okay, and again, square root 2 times square root 2 is simply 2. So this is 2 times 7, which is 14. Now, sometimes you're going to have to work backwards. So sometimes they're going to give you the hypotenuse, and you need to find the 2 legs. And sometimes that's easy, and sometimes it's a little bit more difficult. So let's say this is 11 square root 2. Okay, that should be pretty easy. If this is 11 square root 2, then your n is 11. So you would put 11 here and here. Okay? So just like up here, 5 square root 2. 11, 11, 11 square root 2. Okay? Now, what if they give you the hypotenuse, and this time it's a whole number? So let's say that this is 18. Okay, let's look up here. When this was a whole number, the legs had a square root 2 with them. And the coefficient there, the number in front of the square root, is half of 6. Same thing happened here. This was a whole number, so these had a square root 2 with them. And what was the number out front? It was half of 14. It was 7. Okay, so the same thing's going to happen here. If this is a whole number, we're going to have square root 2 numbers here, and the number in front is going to be half of 18. It's going to be 9. Now, why is that? Why does that work? This is your n. This is your n. This side would be n times the square root of 2. And when you multiply that out, square root 2 times square root 2 is 2, and 2 times 9 is 18. That's why it works. Okay? And you don't need to write this here. I'm just showing you why that worked. N. This is n square root 2. It's 9 square root 2 square root 2, which simplifies to 18. Okay, let's do a couple of the 30, 60, 90 triangles. Okay, so here is our model 30, 60, 90 triangle. Okay, all 30, 60, 90 triangles look like that. Okay, so let's say this is 6. Well, that's your n. The hypotenuse is supposed to be 2n, so it's supposed to be 2 times 6, or 12. And then this side is supposed to be the n, the 6, times the square root of 3. So this is your n, this is 2 times n, this is n square root 3. Let's do another one. We'll keep it easy again. This is 4. This will be 2 times that, so it'll be 8. And this side will be 4 square root 3. Okay, sometimes they'll give you the hypotenuse. So let's say that this is 20. That is your 2n, so your n is half of that. Your n is 10. Okay, just like all of these. This is 12, this was 6. 8, 4. 20, 10. Okay, and then this side is 10 square root 3. Okay, and sometimes they'll give you this side. Let's say it's 9 square root 3. Well, then this side's 9, and this side is 2 times that, 18. Okay, where it gets tricky is when this is like 2 square root 3. Okay, because remember, n can be anything. This n can be a whole number, a decimal, a fraction, a square root, can be anything. So let's say that your n is 2 square root 3. Well, this side is supposed to be 2 times that, so it'll be 4 square root 3. And then this side is supposed to be n times the square root of 3. Okay, square root 3 times square root 3, that's just 3. 3 times 2 is 6. So you're going to end up with a whole number over here. It is 6. Okay, now the question is, how do you work backwards from that? So what if they give you a whole number here? So what if this is 15? How am I going to find this? So you can say 15 is your n square root 3, and you can solve for n. So divide both sides by square root 3. This is your n. Okay, you have n by itself, but we're not supposed to have square roots in the denominator. So we multiply by square root 3 over square root 3. And we end up with 15 square root 3 in the numerator and square root 3 times square root 3 in the denominator. And remember, when you multiply those together, you just get 3. And then that simplifies. 15 divided by 3 is 5. So your n is 5 square root 3. And then your hypotenuse is supposed to be double that. So it is 10 square root 3. Okay, and then finally we are going to review some trig. Okay, so sine, cosine, and tangent. When do you use those? Okay, I'm going to show you 3 quick examples. One using sine, one using cosine, and one using tangent. Okay? All right, so the first one. Okay, here's the problem. We can't use 30, 60, 90 triangle because it's not a 30-degree angle. We can't use 45, 45, 90 because it's not a 45-degree angle. I can't use the Pythagorean theorem because I only know one side. To use the Pythagorean theorem, I have to know 2 sides. Okay? So then my only option is trig, and I have to decide which one of these I'm going to use. So I start at the angle, and I circle it. Okay? And I say from that angle, which 2 sides am I dealing with? This side is opposite, and then this side is adjacent. I don't care about the hypotenuse. I don't know it. I don't want to know it. I want to know opposite. I already know adjacent. And you'll notice that opposite and adjacent go with tangent. So I'm going to write down tangent, and you always put the angle next to it. So you're going to put 31 next to it. And then you're going to do opposite over adjacent. So opposite is x, adjacent is 10. Okay, I'm going to darken that in. This is our original equation. Now we have to try to get x by itself. So how do I get this x by itself? How do I get rid of 10? I multiply both sides by 10. And I end up with 10 tangent 31 equals x. And then I can plug that into my calculator. So 10 tangent 31, enter. It's approximately 6.0. Okay, let's do another one. Okay, so on this one, again, I'm going to circle the angle. I know the opposite side. I want to know the hypotenuse. Oops, sorry, didn't realize you couldn't see that. Okay, so opposite and hypotenuse. That goes with sine. So I'm going to go sine, and then I always put the angle next to it. And then I do opposite over hypotenuse. Okay, so again, I'm going to put this original equation in black so that I can see it at the end. That's how I start the problem. But then I have to get x by itself. even if I got rid of the 12, I wouldn't have x. I would have 1 over x. To solve for x, it can't be in the denominator. It's got to be in the numerator. So I am going to multiply both sides by x. That'll cancel. Here's x now. But I still need to get it by itself. I have to get rid of sine 40. Sine 40 is just a number, so we're going to divide by sine 40. If I do that on the left, I have to do that on the right. Okay, so this cancels. So on the left, we just have x. On the right, we have a 12 in the numerator. The x is canceled. And we have a sine 40 in the denominator. And then we're going to plug that into our calculator. So 12 divided by sine 40. And we get approximately, I'm going to round to the nearest tenth, so that's this first digit. The number next to it is 5 or greater. So that means I need to round up to 18.7. Okay, and last problem. Okay, so this time you actually want to find the angle. The angle is our unknown this time. So I still start at the angle, I circle it, and I figure out which two sides I'm dealing with. This is the adjacent leg, this is the hypotenuse. Adjacent and hypotenuse go with cosine. So cosine, I put the angle next to it, my angle is x, and then I do adjacent over hypotenuse. Okay, let's put that in black. This is our original equation, and then I'm going to have to try to get x by itself. Okay, so to get x by itself, I have to get rid of cosine. To get rid of cosine, I have to do the opposite of cosine, which is cosine inverse. If I do that on the left, I have to do that on the right. Okay, these will cancel, and you'll just have x equals cosine inverse of 10 over 15. And then you can plug that into your calculator. You're going to hit second cosine, and then 10 divided by 15. And you get approximately 48 point, this 8 means I have to round this up to 2, 48.2. Okay, and that concludes our Chapter 8 review. All of these notes will be on Canvas to help you with your Kahoot. Thanks, guys.